So ADS-B is the cheapest, smallest detect and avoid capability that's out there. And in a lot of airspaces, captures a significant percentage of the aircraft. Not all of them, because they're not all equipped, but a significant percentage. The FAA has recognized this, and they have started producing waivers, exemptions, and summary grants of usage using only ADS-B as a means of detect and avoid. This wasn't the case, just call it 3 years ago. You had to have ADS-B and something else. But now there are drone as first responder or DFR standard summary grants where you can use ADS-B only if you are flying up to 200 feet. So if you're a law enforcement agency and you want to use drones and you've got an ADS-B receiver, they don't even say it has to be on the drone. You could put it at the launch site. And you want to only fly up to 200 feet, have at it.
Welcome to The Vertical Space, the podcast at the intersection of technology and flight, featuring deep dives with innovators, early adopters, and industry leaders. We are your hosts, Jim Barry from Celerity 05 and Peter Shannon and Luka Tomjanovic from Radius Capital. At Celerity 05, we believe that breakthrough air transportation capabilities come from leveraging current and emerging technologies, and that companies achieve profitability through relevant technologies, strong teams, and a deep understanding of the aviation market. Connect with global aviation experts at celerity05.com for feedback and recommendations to chart your path to success. At Radius Capital, we invest in early-stage deep tech that redefines what is possible in aerospace. We partner with founders building next-generation aerospace capabilities, from advanced design and development tools to the digital transformation of the flight environment, novel use cases and forms of flight, and the software and systems that make them possible. If this describes you, reach out. We're excited to connect. All right, let's dive in.
Hey, so welcome back to The Vertical Space and our talk with Christian Ramsey, Chief Commercial Officer of uAvionix. It's great when you can interview returning guests. Christian last joined us in September of 22. One of the great benefits that time provides is to hear what actually happened from the many predictions that were made several years ago as it relates to the intersection of aviation, advanced air mobility, and technology. You hear why many things actually occurred, or perhaps why they were delayed. Oh, the many lessons many have learned on the challenges and the careful path you have to follow when introducing technology to aviation. It's a lot harder than most people realized. Now, with Christian and uAvionix, they've talked the talk and they've walked the walk. And they continue to deal with real use cases, with real and practical solutions that people pay for and in return receive measurable value. We start with how Remote ID has failed to live up to expectations. He explains why Remote ID had been chosen and how it turned out to be, in Christian's opinion, a big stinking failure, and that performance was compromised for the sake of low-cost or no-cost system. We then get a course on ADS-B and its role and value, starting with an overview of ADS-B, what it is, its original use cases, how it works, and whether or not it too has lived up to its promise. We discuss the importance of full equipage and the challenges of partial equipage and partial usage. We discuss its full potential, including achieving electronic conspicuity. I still remember the comments during the financial justifications of ADS-B many years ago that we would retire most of all our traditional radar systems. And here we are in 2025, and those radar continue to be relied upon, and for many good reasons. Good to keep in mind as we prognosticate changes and adoption of aviation technology into our national airspace system. We then get a good history lesson of radar, mode A, C, and S, and then we work into the adoption, as I said, and the dream of ADS-B. We then discuss the recent aviation accidents and incidents and what potentially could have been done to minimize the risk. We discuss some of the same with our recent guest, Captain Lee Moak. We discuss how, in Christian's opinion, ADS-B is the cheapest and most effective means of detect and avoid, and discuss its applications within Part 108 and achieving the reality of electronic conspicuity. We discuss the Surface Awareness Initiative system, the deployment of low-cost surface monitoring systems, uAvionix's role, and how it's a complementary capability to existing systems, and potentially the analog to other areas of situational awareness. Finally, we discuss the current trends in aviation, including docked drones, as well as avionics and drones, and what has changed most since our talk in 22. By way of background, Christian Ramsey is the Chief Commercial Officer of uAvionix and a member of the FAA Drone Advisory Committee since 2020. Christian's career includes positions at Harris Corporation, ITT, Rockwell Collins, and NLX. He started his career as a software engineer with Lockheed Martin. We also want to thank Christian and uAvionix for sponsoring our podcast. So many thanks to Christian for a terrific discussion, and it was great to have you back. And to you, our guests, we hope you enjoy our talk with Christian Ramsey as you profitably innovate in the vertical space.
This episode of the Vertical Space podcast is brought to you by uAvionix. uAvionix is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let uAvionix help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. uAvionix has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace. Christian, welcome back to the Vertical Space. It's great to have you on the show again.
Thank you. It's great to be here, Luca.
You know that we usually start with asking the question of, is there anything that few in the industry agree with you on? How would you change that answer from the last time that you were on, or how would you address it today?
I didn't go back and listen to my previous answer, so do you
Wait,
remember what it
what?
was? Do you remember what my previous answer was? But I do suspect that you guys get a lot of these statements. They say everybody disagrees with me, but they're pretty well accepted statements, and mine might be too. But my answer is that remote ID is terrible. It has failed to live up to its need, and we're going to suffer because of that.
Okay, so for those who might not be familiar with remote ID, do you mind catching the audience up on what the intended goal was and how it failed to achieve it?
Yeah, so several years ago, there was an initiative by the FAA to develop and standardize and enforce a technology that was generally called remote identification. I call it remote ID or just RID sometimes in my writing. But the idea was it was kind of a blocking factor for some rulemaking that needed to get done, specifically flights over people, where some of the other agencies, government agencies, said, look, we can't let you allow flights over people if we don't know who it is that's flying, and therefore the idea of remote identification was born. We needed a way to point something at a drone in the sky and have that thing tell me who that drone belonged to, and ideally where the pilot of that drone is, so that if I'm a law enforcement officer, I can go find that person and question them. I was a part of the Aviation Rulemaking Committee, the ARC, for that system, and we examined every conceivable technology that ranged from ADS-B, which we'll talk about a lot today, to flashing lights, Morse code in the sky, to what was ultimately chosen, which was a Bluetooth or Wi-Fi beacon technology. And the reason we settled on Bluetooth and Wi-Fi was because there was a strong preference by the FAA that they did not want to impose any costs on the law enforcement community. So they didn't want the law enforcement community to go have to buy a receiver in order to achieve this objective. And so the idea was, well, everybody's phone, whether it's a Samsung, Apple, whatever, has a Bluetooth and Wi-Fi receiver in it. And therefore, if we standardize on that technology, everybody's got a receiver in their pocket. That's the standard they chose. That's the standard that they've mandated since some point last year, maybe the year before. Every drone produced and imported into the US has to have this technology on board above a certain size. But the problem is that, those are two things. One, those are very, very crowded signals, and the antennas in your phones aren't really designed for long-range detection of that capability. So you really have to be really close to get a phone signal reception from those drones broadcasting on Bluetooth or Wi-Fi. And it's kind of useless. And the public doesn't know much about it. The law enforcement community still doesn't know a lot about it. They don't know that they've got this tool capability. And it turns out that they've got to go pay for expensive infrastructure anyway because to get any meaningful range out of it. And I think we saw this with the New Jersey drone scare, where nobody knew these things were flying, but it was a great opportunity for the FAA to come out and say, hey, everybody, there's this technology that if you're seeing drones, they're broadcasting a signal, and here's how you can see it. Rather than capture photographs of phones in the sky, download this app, capture the data, send us that data, we'll figure out who it was. That didn't happen. And so I just think it's, turned out to be a big stinking, failure from an technology implementation perspective and an enforcement perspective. Really looking forward to seeing where they go with this next.
What's the threshold for the size of the UAS that needs to have this, and what are the effective ranges?
I think it's similar to the threshold that you have to register your drone. So 249 grams, I think, is the threshold for if you're registering a drone. That drone should do it. From a phone, you may get a couple hundred yards. Right now, I hear that some installed systems. There are some companies like Pierce Aerospace that install, dedicated infrastructure, drone tag, dedicated infrastructure. They may get a couple miles out of it, but that's typically in a pretty RF free environment where they're going to get those maximum ranges to see. But you're still only getting a couple miles out of it. But if you're using your phone, and by the way, Apple only supports one of two, doesn't support the Wi-Fi beacon capability. So if the drone is broadcasting on one of two approved systems, the Apple phones won't hear it at all anyway.
I'm really surprised that when the ARC was evaluating these decisions, that there wasn't an anticipation of the range issues that we're just talking about. I mean, to what extent was there technical demonstration, diligence, feasibility studies?
I think it was pretty poor. I mean, I think that there was a huge urgency to get something done, much like when we went through Part 107 in the original registration. It was identified as a blocker to flights over people, and therefore we needed to get something done and something mandated so that we could get to that point. And it was not evaluated from a range or performance perspective. I was trying to advocate for a system that could be used doubled as a detect and avoid capability with enough range to get you, detect and avoid capability. But the single biggest priority was cost for a law enforcement agency to receive this function. Yeah, it's disappointing. We compromised performance for the idea of cost, but in the end, we didn't achieve the cost savings, right? So we compromised performance that could be used for either longer range security purposes. The FAA was very clear that this was not a detect and avoid capability, it was for security purposes. But we compromised performance that could be used for detect and avoid or for effective security performance to achieve a low cost, no cost receiver solution. But then that turned out not to be true because the performance reductions were so great that it's not practical. And then they have to go spend money to install these, infrastructure-based systems anyway. And so we failed on the cost and we failed on the performance.
So what should we do, Christian?
Well, my advocacy during the ARC was we need something probably on a dedicated spectrum. We talked about ADSB back then, but we also talked about an ADSB-like system on a dedicated spectrum that could be a higher power, longer range system that would only be used for this purpose, right? There's a lot of spectrum discussion in the UAS industry and a lot of discussion about avoiding interference, avoiding spoofing, avoiding all sorts of environments. And to me, this is not quite a safety of life application, but if you could use it for detect and avoid, it would definitely be a safety of life application and would deserve having its own, dedicated ADSB-like channel.
Just the other day, 978 came out as a dedicated spectrum over in Europe. That was some pretty big news. Would that help in this situation? Is that a corollary that may apply?
Thank you for highlighting that. Just released an article about that this morning. That's something that we have been right in the middle of for the past 8 years, working in the UK. It's the UK, not Europe broadly, but it's in the UK. And 978 spectrum is an ADSB frequency in the US. It's an international standard for an aviation dedicated frequency. It is not used anywhere but the US. And so this creates a really nice opportunity for a clean signal everywhere but here for this purpose. And the UK CAA recognized that and started working with us on several trials over the course of several years where we were flying equipment on aircraft, installing equipment on the ground, broadcasting signals from the ground, and ultimately Ofcom, which is their equivalent of our FCC and the CAA, this week matured their rulemaking into a use of 978 megahertz ADSB UAT for drone operations, and that's ideally for the concept of remote identification, but it is also for detect and avoid. So very, very happy with that decision and the direction they're going. Hope others follow suit.
So, since we're revisiting ADS-B, and we'll spend a good chunk of time talking about ADS-B and aviation safety, how about we do an overview of ADS-B again for the audience who might not be up to speed on it? So, give us a quick intro to ADS-B, what it is, how it works, all the facts.
To really appreciate ADS-B, you have to sort of think back to a time when our use of GPS was not so ubiquitous, right? We know our latitude longitude coordinates very easily from our watches, from our phones, but in aviation and 20 years ago, that was not the case, right? So the way that we tracked aircraft in the sky, you know, even 10 years ago, and even today, I should say, right, is through radars, right? And so you've got these massive energy emitting antennas that spin. Sometimes they're once every 5 seconds, sometimes they're once every 12 seconds, and it bounces energy off the aircraft, and that signal comes back. And when you've got such a huge mechanical system like that, what you don't really realize is that precision isn't precise. We know pretty close to where that aircraft is, but we don't know exactly where that aircraft is compared to what we know what a GPS signal's precision is. And so that's why air traffic control separates aircraft by miles, right? 5 miles of separation between one aircraft to another aircraft laterally because of that lack of precision of a radar system. So around 2010, 2011 timeframe, the FAA started a program called NextGen, and NextGen was to implement a bunch of programs across the air traffic control system, but one of the key ones was implementing ADS-B systems across the National Airspace System, or the NAS. ADS-B takes the power of GPS and the precision of GPS and translates it into an aircraft space, right? What it is it's a physical piece of hardware that exists on the aircraft called a transponder or an ADS-B transponder, and it's connected to a GPS, and it knows exactly its precision, and it knows how good its GPS signal is, and it sends that out at least once per second to everybody else that can hear that signal. And that signal is not encrypted. That signal can be heard by lower cost receivers, either portable receivers in some aircraft or ground-based receivers on the ground, and they can be heard from very, very far away. And so you've really improved the accuracy of aircraft tracking by using the GPS signal that's on the aircraft itself. The side benefit of that is that now all of the aircraft in the sky with an ADS-B receiver can see each other electronically. Electronic conspicuity is a phrase that's used a lot now. They can see each other in the sky, whereas previously they had to see each other with their eyeballs, or they had to have air traffic control tell them you've got traffic at 1 o'clock 3 miles. Well, you're looking out the window and you may see it, you may not, but you know about where it is. But if you were to look at a moving map, you would see a dot on that map or a chevron on that map that would tell you exactly where it is, exactly its speed, exactly how much higher or lower it is than you, and the direction it's heading, and you can self-separate and correct your course. That turns out to be a fantastic detect and avoid capability as we move into advanced aviation, AAM drones, right? And so being able to have drones detect ADS-B signals is the lowest cost, cheapest, and highly accurate way to achieve that.
As part of NextGen, what were the original use case applications for ADS-B, and which ones have proven out to be the case and which ones have not?
There's a cost component, right? So it's cheaper to maintain, frankly, right? So there's a cheaper system to operate from the NAS perspective. That's one thing. More capacity in the sky. When I say more capacity in the sky, I mean you can take that 5 miles of separation that I mentioned that they separate aircraft by, and you can shrink that down. And now they're talking about 3 miles of separation in certain airspace. And so literally you can fit more aircraft in the sky, which sounds weird when you look up, you don't see any airplanes. But from an air traffic control perspective, they're fitting more aircraft in the sky because they've got higher accuracy and confidence in where those aircraft are. And those, I think, have somewhat rung true, right? So in some airspaces, we are fitting, lower separation minima in the sky. The concept was that we would be able to retire some, not all, of our radar assets and reduce costs by maintaining them. Not much has happened there. not much has happened there at all. Maybe one or two systems have been retired, but that's not happening much. There was concepts of improved routing, right? So instead of land-based navigation age, you can have more direct routes and improve routing, which saves fuel.
Like over the Gulf, for example, that was
Correct.
one of the ones that was constantly used to justify it, right?
Yep. Yep.
Outside of radar coverage.
That's right. Yep. And so that's another example of something that really hasn't come to fruition.
You did notice that I didn't mention the name of the Gulf.
Just the Gulf. We'll just call it the Gulf.
Christian, what is the difference between ADS-B and the various modes of transponders, and how do you compare and contrast?
Okay, great. Thank you. This is a history lesson. So we start back with this starts back at World War II. So in World War II, the advent of radar and identification, friend or foe. So you needed a signal. You needed a way to tell enemy aircraft from your aircraft, and this is in the UK where this started. And so if you've got a radar spinning and you're seeing a bunch of dots on the screen, you don't know who's who. So we need something on the aircraft that tells us who's who. And so the first way became the first transponder mode, which was called mode A, right? Mode A is a transponder code 1 2 3 4, something like that, right? And the mode A, when that transponder hits the signal on the aircraft, it responds with this mode A code, and it says I'm 1 2 3 4, and the other aircraft's 2 3 4 5, right? And so now I can start to tell the difference between two different aircraft from that perspective. It's not unique to the airframe. Every flight has a different code. They get reused, but that's what mode A is. The next transponder mode is mode C. Well, radars can't really judge altitude very well. They can tell distance, but they can't judge altitude very well. So mode C added an altitude encoding from the aircraft. So the aircraft's got a barometric altimeter on board, and so when it gets hit with a mode C interrogation, it's an interrogation. The radar asks a question, the transponder replies with an answer. The mode C transponder answers with the aircraft altitude. So now I have a unique code, and I've got an altitude, and I've got a location that's provided by the radar, right? Still, this is pre-GPS. The next mode is mode S. Well, pretty soon we start asking. There's lots more airplanes in the sky, and everybody's replying to these interrogations, and it starts to get really noisy and really jumbled, right? Because now we've just saturated the sky with all of this RF messages and bouncing back and forth, and it starts to get confusing. And so now we need a way to identify just one aircraft and ask that just one aircraft a question versus asking everybody. And that's mode S, with the S being for select. I can select an aircraft and I can ask that aircraft that selection. And with mode S comes a unique identifier just for that airframe. Every time it flies, it's got a unique identifier, right? And ADS-B is actually an extension of mode S. So what it does is it transmits the same types of information that you would get from a mode S interrogation, but it does it automatically. That's what the A is in ADS-B, automatic, right? And so that transponder is automatically just saying, here I am, here I am, here I am. I don't need to listen to for the interrogations from the radar.
Great history. Talk about the difference between mode A, C, and S and ADS-B as it relates to your ability to change it, let's say, on the fly, so to speak. Isn't there some criticism of ADS-B that it can be, quote unquote, manipulated a little bit more than AC or S could be?
It can. So an interrogation response system is mode A, C, and S, right? Pre-ADS-B. The transponder is only going to reply to that interrogation. With ADS-B, it is the term I think you're looking for is spoofable, right? So it's not an encrypted signal. It's not an authenticated signal, frankly, right? So if someone had the right equipment, they could transmit false or misleading information into the airspace and make someone think there is an aircraft where there isn't an aircraft. I think in practice, we haven't truly seen this happen yet, right? I think we've seen a lot more GPS spoofing types of applications in the airspace rather than, kind of a spoofing from an ADS-B perspective.
Isn't it also true that given that ADS-B picks up the GPS signal from the onboard sensor on the aircraft and then broadcasts that as part of the signal, it relies on having a high integrity / certified GPS receiver? Otherwise, it could be sending erroneous position information.
Yeah, that's right. Yeah, so the GPSs that are paired with the ADSB transponder, they have to have a TSO certification or certain quality levels associated with them. Part of that certification involves detection and removal of signals of suspect. So if it's not a great signal from a satellite, or if it looks like it's being incorrect or degrading in some way to the GPS signal, those signals get discarded from the calculation, from the GPS calculation. That's not to say that it eliminates, the problem, but there is a quality level associated with the GPS for ADSB. Yes.
So, a question on the airframe unique code associated with ADSB or MODES for that matter. Is it the tail number of the aircraft? Is it the registration number, or is it a different code? And where does that tail number come into the picture in this data exchange?
Yeah, it's not the tail number. It's a 24-bit address called an ICAO address. And so you're limited to 2 to the 24, right, combinations in the world of aircraft with having an ICAO address. In the US, there is actually a formulaic algorithm that will convert the tail number to the ICAO address and back. That's not true everywhere. So every country's registration number is not necessarily convertible to the ICAO address.
And as we step back, and you talked about the next gen, you talked about the ADSB deployment. We just had Lee Moak on recently, and he talked about next gen, some of the successes of next gen. Many people argue this was one of the few successes of next gen. But at the end of the day, have the use cases largely been fulfilled through the deployment of ADSB? There's clearly been benefits of ADSB, but it largely has not fulfilled the billions that are required to deploy it. Is that the case, would you say?
I think it has for commercial aviation, largely. So where and to be fair, it was probably initially fully designed for commercial aviation because that's the bulk of aviation that happens in controlled airspace in the NAS, right? The secondary benefits of air-to-air self-separation, I won't say collision avoidance, but the air-to-air self-separation, we're not realizing the full benefits there. And the reason for that is we're not fully equipped. So if I use the term universal equipage, it means the idea that every aircraft has ADSB on board. And so we're not there, right? So the US's aircraft registration database has roughly 200,000 aircraft in it, right? So about 200,000 aircraft in the US registered aircraft. There's a web page you can go to on FAA.gov that shows you how many aircraft are equipped with ADSB. There's about 170,000 aircraft equipped with ADSB. Pretty high percentage, right? Pretty high percentage there. We don't know, or I guess I'll say it another way, we don't think all 200 aircraft are in flying condition because there's a whole bunch of aircraft that are sitting on tarmacs out there that are rotting, but they're registered to someone, right? So somewhere between 170,000 and 200,000 aircraft, so somewhere between, call it 20,000 to 30,000 aircraft, don't have ADSB on board because they don't have to. It's not mandated that they have to. And most of these aircraft are general aviation aircraft. You can kind of consider that all commercial aircraft do, right? Because they're going to fly into the airspaces that require it. All biz jets do, right? We're talking about little aircraft now. We're talking about your single engine piston aircraft. We're talking about, possibly small private helicopters, crop dusting aircraft. The ones that are likely, frankly, the most at risk for collision with a drone because they're flying at lower altitudes, right? And so this gap, right, this is a uAvionix niche. We were trying to solve this problem for this crowd of developing ADSB solutions for the most at-risk communities at a price point that a 40-year-old airframe could bear, right? And one of our early successes was creation of product called Sky Beacon and Tail Beacon for those systems. And so those benefits are still not fully realized. And we hear the news feeds that I listen to quite frequently of mid-air collisions just between GA aircraft, right? There was one in Arizona not too long ago, right? The two aircraft in the pattern could very easily have known that each other were there, but they didn't have the equipment on board that would tell them that they were encroaching on each other. So that's, leading into the recent accident at DCA. The helicopter did have ADSB installed. It did not have it turned on, as we learned, right? We learned that from some part of the investigation. It didn't have it turned on. Would that have averted the accident? I can't say that for sure, right? But it was another safety layer that was sort of turned off in that space. I do think that if the helicopter had an ADS-B in receiver on board, that it would have had that electronic conspicuity visibility of the airliner coming in for landing, and could have averted that. And back to one of your questions about the baselines of ADS-B, I didn't talk about ADS-B out versus ADS-B in. So ADS-B out is a term used for an aircraft that's transmitting, and ADS-B in is a term for listening, right? So the mandate applies to making sure that everyone is transmitting in certain airspaces, but there is no mandate for listening for others. That's a voluntary.
Christian, if
voluntary
I
thing.
may, real quickly, your widely read February 19th piece after the accident was, a rant about ADS-B's role in preventing midair collisions. That was a great piece. But is the essence of it, had the helicopter had the ADS-B in, they would have seen where the commercial airplane was?
That's the essence of it. Yes, my I called it a rant because I have been in the ADSB industry since pretty much its beginning. And I feel like it is a truly life-saving capability. And this was an accident that occurred in not only commercial airspace, but probably the most surveyed, radared commercial airspace in the country, right? A mile from the White House, right? And we still missed it. And it was missed. It could have been self-prevented if the helicopter or the airliner had ADS-B in capability and they could see each other, right? And not going to say that it absolutely would have, but it certainly would have helped and could have done that. And so my rant was, well, first of all, why did the helicopter, why was it turned off, right? Frankly, right? And I don't know that would have changed anything in the cockpit of the airliner. But if they had an iPad with a receiver on board, then like most general aviation pilots do today, they would have seen the other aircraft coming on board.
Is it true that the pilot of the helicopter was under night vision goggles at the time? Wasn't it a
That's
training
what I
mission?
think. Yeah.
And and do those rotorcraft, if they do have ADS-B in, is there a way to transmit that information to the pilot if the pilot is using those goggles?
I don't know, honestly. I
Right.
not that I know of. I think there is a limited field of vision.
Yeah.
I can't imagine what the view from the cockpit over DC would have looked like through night vision goggles with all
Mhm.
the cityscape that's there, right? I mean, there must have been just lights, lights everywhere, blaring in those goggles, right?
Yeah.
So I don't think there's anything like, we've certainly had internal discussions about it lately, but, augmented visions or alerts or things like that could be projected into the goggles, right? There's certainly ideas there that we could explore, but even just an audio sound could have been enough to make them turn their head.
I mean, they're focusing on landing the plane, right? And they're in Class B airspace, cleared to land.
Yep. They have full trust in the system at that point.
In my experience as a pilot, that's not a time where I'm trying to see and avoid other traffic. I'm
That's
not
right.
dodging helicopters on the way down to the threshold.
Yeah.
So I, I just think it's kind of a ridiculous situation that you have this type of helicopter traffic operating that close to a short final approach path to a
Yeah.
towered airport, much less to DCA. It strikes me as incredibly cavalier that they were even doing that.
Just 2 days ago, the NTSB's preliminary report showed how close that helicopter route was to that glide slope, 75 feet at best, right? That's just terrible.
And it also mentioned how many times that's happened in the recent past, which Lee talked about in his podcast. And I believe they recommended that there be greater separation. That was their recommendation of the FAA on Tuesday, I think it was.
Yeah, that's
I mean,
right.
other things that we try to get the FAA to allow in the airspace system, we spend years trying to make the safety case and get those things going. And then at the same time, that same organization has had this type of an operation going on at a major airport for years. Boggles my mind.
Okay, back to equipage. Obviously, not everybody is equipped despite the mandate, and some have valid exemptions. Those older aircraft that don't even have an electric system, for example. But more broadly, let's talk about the pushback that the industry is given to universal equipage for ADS-B. What are some of the common and also valid objections to ADS-B?
So, four things. The first item is cost, right? Nobody likes to be told they have to spend money, right? And the typical general aviation aircraft is quite old, right? It may have a hull value of $10,000 or $15,000. The avionics on board are probably worth more than the aircraft, body itself. And so being told they have to spend anything is an objection point, right? Second objection is privacy. There are a lot of concerns that Big Brother's watching, right? And unfortunately, some recent events in the last year have highlighted that there are big brothers out there watching, right? And so, for example, there was a bit of a controversy this past year in Florida where ADS-B was used at small municipal airports to automatically detect aircraft landings and send landing fees out, right? And so you've taken a safety system and turned it into a revenue generating system. And from a pilot's perspective, you've got a tax on something. I was forced to buy this and install it, and now every time I fly somewhere, I'm going to get a bill because I'm doing it, right? And
But they could have done that with Mode S without the EDSB.
they could have, yeah, but it's a lot more expensive for the airport to implement a system like that, right? With if they didn't have a radar system on board, right? So they have to install a multilateration system. Now they can install a single ADS-B receiver and collect that data. So it's a lot easier to do that. We saw in the FAA Reauthorization Act last year some positive language that ADS-B shall not be used to initiate an investigation. So if there's a pilot doing something that they shouldn't be doing, ADS-B data can't be the reason that they go after that pilot. So now something else could trigger it, and they could look at the ADS-B data to corroborate that. But there's some positive language there, and rightfully so. Organizations like AOPA are pushing back against these non-safety uses because it's a deterrent. It's a deterrent to safety if there's going to be some other penalty for using this technology, and we support that. And so cost, privacy, inappropriate use was that third one. You mentioned spoofing earlier. That's a theoretical and technically possible objection, but we haven't really seen that happen yet, as far as I'm aware. And then spectrum is often cited as a potential objection as well from the more technical folks, and this turns out to be more on the drone side than on the crewed aircraft side. So no ADS-B out on drones is a pretty established policy here in the U.S., unlike in the UK. But that was for spectrum preservation reasons.
And how does that manifest? The traffic controllers are pushing back against an overload of broadcast data that they have to parse through, especially if this is opened up to drones. What are the consequences of congesting that spectrum?
I mean, you can kind of draw the analogy just to trying to have a conversation in a crowd, right? Where there's just so much noise going on that the communication is not clear, right? And so whether it's an RF or audio communication, if you're trying to talk to somebody across the room and there's a lot of noise around, you may get bits and pieces of the messages, but they don't come through. It's a very similar idea in the RF world. If you've got a lot of messages that could be stomping on each other from reception perspective. From the controller perspective, there is the idea that, wow, there may just be too many things on the map. I kind of discount that one quite heavily because filters are pretty easily implemented, and if you want to filter out aircraft that are below a certain altitude or filter out drones period, that's encoded in these messages are the altitude, what type of aircraft it is, so you can easily filter out data that isn't relevant to what you're trying to do.
So one of the interesting pieces from your rant article was how you're describing this unintended consequence of partial equipage, where you end up running two technologies in parallel, the new gen and the old gen, and the problems and the cost and safety concerns that creates. Do you mind talking a little bit about that?
We hit on it a little bit in that we have not been able to retire old systems as projected with the old radar systems that are out there. The idea was that, hey, we're going to transition to a dominant ADS-B surveillance network backed up by radar, right? We're still radar first, ADS-B second, right? And what that does is, our dependence on the radar means that we still have to maintain all of the cost of now running dual systems, right? And so there's a huge technical and financial cost to maintaining a lot of those old legacy systems. And if you watch Secretary Duffy's press conference this week, he talked a bit about that, right? There's just a huge cost to maintaining some really old stuff out there. Some of the other aspects are sort of how do air traffic controllers operate, right? So if they're operating aircraft in the same airspace and some of them are ADS-B equipped and some of them are not, well, they kind of have to manage to the least common denominator, right, in order to have the biggest risk tolerance in that airspace. If everyone's operating on a common technology system, then operations go much more smoothly. But now you've got this crowded airspace and this one oddball comes in and he's not equipped, and now everybody's got to sort of part the waters for this person to sort of work through with a wide berth. It's just inefficient use of the airspace, and it's kind of like a traffic jam. Everything trickles down to delays, right? So turns and hold patterns translate to delays on the tarmac and delays at the gate, and and all of these things are cumulative in their overall effects across the whole NAS.
Are there any examples of terminal airspaces, Class B or otherwise, that are solely and primarily relying on ADS-B for traffic separation and control?
Every Class B airspace is ADS-B airspace, ADS-B mandated airspace, as well as an area around a Class B that was previously called the Mode C veil.
Right.
Now it's called the Mode C/ADS-B veil. But the Mode C veil is a 30-mile circle around the center of a Class B airspace. So,
But my understanding is that ADS-B is still in a backup secondary function.
but you have to be equipped to get there, right? And so they are operating that airspace as if everyone is equipped. And if you wish to enter that airspace without ADS-B equipage, you actually have to sort of register ahead of time and tell them you're going to be coming in so that they're prepared for you.
Time back to our earlier conversation about the resolution and the lack of precision in some of these radar systems. I don't think that's necessarily the case for Class B airspace systems, where the radar systems are much better on the ground and you have that higher resolution to be able to use radar for separating traffic closer than 5 nautical miles. And so, what is the role of ADS-B here in terms of squeezing more traffic in a given volume?
I think the squeezing more traffic in a given volume is more relevant to the en route airspace, frankly, than it is in the terminal airspace, because I think you've got a pretty crowded airspace in the terminal regions anyway, because that's the hubs of all the activity that's coming in. So it's more about the en route airspace for reduced separations.
Okay, so how does ADS-B then fit into the drone part of the industry? And what can we expect from Part 108 with respect to ADS-B?
An ADS-B receiver for a drone at best is a less than a postage stamp size chip that either gets added on to an existing drone or literally built into the circuitry of the drone, depending on what it is. So it can go on Group 1 drones or consumer level drones. If you're familiar with DJI, they have several years ago committed to incorporating an ADS-B receiver on every drone that was larger than 249 grams. So for some reason, the industry settled on 249 grams as the threshold for registering, the threshold for remote ID, and for DJI's purposes, the threshold for ADS-B equipage, right? So it's very inexpensive and high performing in terms of range detection compared to literally any other technology for detect and avoid. So if you have to put a radar on a drone, or if you have to put a camera on a drone, you're taxing that drone with a lot more weight. You're reducing its payload capability, you're reducing its range or time to flight capability, or you're increasing the size of the drone in general because you've got to put these other systems on board. So ADS-B is the cheapest, smallest detect and avoid capability that's out there. And as we've talked about, in a lot of airspaces, captures a significant percentage of the aircraft, right? not all of them, because they're not all equipped, but a significant percentage. The FAA has recognized this, and they have started producing waivers, exemptions, and summary grants of usage using only ADS-B as a means of detect and avoid. So this wasn't the case, just call it 3 years ago. You had to have ADS-B and something else. But now there are drone as first responder or DFR standard summary grants where you can use ADS-B only if you are flying up to 200 feet. So if you're a law enforcement agency and you want to use drones and you've got an ADS-B receiver, they don't even say it has to be on the drone. You could put it at the launch site, and you want to only fly up to 200 feet, have at it, right? Same for a lot of shielded operations, for drone in a box operations, utilities. A lot of drone in a box companies like Skydio, Percepto, etc., incorporate ADS-B receivers for their drone in a box applications because they get a waiver and they don't have to add a radar, they don't have to add a camera, and they get to fly those operations. So the great news here is that the FAA has recognized that, okay, equipage levels on manned aircraft are getting to the point where I am mitigating a significant amount of risk if I can just have ADS-B on board as the first line of defense for a drone detect and avoid capability. And so we're still not transmitting for most drones, right? We're still not transmitting ADS-B out, but we are easily listening.
And one of the interesting things about Part 108 recommendations or the BVLOS ARC recommendation was the introduction of portable ADS-B systems for places where ADS-B is not mandated and there is no universal equipage.
Nobody's seen actually 108 language yet, but we do know from FAA panels and things like that that's true. So this all stemmed from the BVLOS ARC recommendations that had quite a controversial recommendation and the idea was talking about aircraft that were flying at very low altitudes like crop dusters and helicopters. If they have ADS-B out on the crewed aircraft, then they maintain their right of way over a drone. But on the flip side, if they choose not to equip with ADS-B out, then they are giving up their right of way to the drone, and it becomes their responsibility to avoid the drone. Now, that's a very hard actual physical task, right? But the point I think the FAA and the ARC was trying to make was, hey guys, it's worth it to equip with ADS-B, right? And so I think that's where that was going. Now, back to the objections of cost, and you talked about the portable systems. What we have been working towards in other countries like the UK keeps coming up because they're very forward thinking, but now bringing that back to the FAA is the allowance of a portable ADS-B transmitter, not transponder, but a transmitter that can be hand carried onto the aircraft, turned on at will, remain anonymous. It's just letting everyone know that you are there as an aircraft and to avoid you. So you can now don't have to spend thousands of dollars to install something on your helicopter. You can spend a couple $100. You can carry it in your flight bag. You can suction cup it to your window. If you're flying a low altitude operation and you hit the button and turn it on and you're broadcasting ADS-B so that those drones that are waivered and legally flying beyond visual line of sight with an ADS-B receiver will see you and everyone remains safe. So that term has been sort of called electronic conspicuity. For some reason, they don't like the term portable ADS-B, but that's what it is, right? Electronic conspicuity devices. They're portable ADS-B systems, and so we believe from the talking points at the symposiums and whatnot from the FAA was it was a little bit of a carrot and a stick, right? So hey, manned community, we're gonna threaten you with loss of right of way, but we're gonna give you a much cheaper way to comply, right? You don't have to go install several $1,000s worth of equipment on your aircraft. Just buy this portable device and you're safe.
So non-cooperative traffic detection and avoidance is obviously one of the holy grails when it comes to BVLOS and remote drone operations. What are the thoughts inside uAvionix on how that is solved? This might be one that we talked about, right? But I could also sense how there might be pushback because you never know how these portable systems might be used. And what comes to mind is, I don't know, maybe a year ago or so, you remember there was this one researcher or one academic in Germany, I think it was, and put a whole bunch of phones in a trolley and then walked them across the bridge. And it showed up as a massive traffic jam on Google Maps. And that resulted in a rerouting of traffic around And so I could potentially see how somebody could play similar games with portable ADSB. But that aside, how is that problem of non-cooperative traffic solved?
There's still only a few technologies that are sort of reliably and repetitively used. There are radar systems. Companies like Echodyne and Fordham and Honeywell are working on low size weight power radar systems. Radar systems, they work. They're heavy and they require a lot of power, and therefore it increases the size of aircraft that it needs in order to carry it. Cameras are another way to do that. About a year and a half ago, uAvionix acquired Iris Automation, and we have now camera-based detect and avoid capabilities, both ground-based and aircraft-based camera-based detect and avoid capabilities. Those systems also have their own limitations. They don't see through clouds. They are, until recently, daytime only, but we've been implementing and testing nighttime capability. They're also limited in range based on the resolution of the camera. The radar systems are similarly limited in range, and there was a study done by NRC in Canada not too long ago that sort of flew camera-based systems and radar-based systems, and there are pros and cons of each. You get a lot more false positive hits you get a lot of radar clutter is what it comes down to, right? With a radar, you don't get that sort of false positive rate on a camera-based system, but the radar systems can have more range, right? So you could be dealing with a lot more noise, but you get more range. Those are really, the two dominant non-cooperative capabilities, and you see a mix of airborne and ground-based systems being deployed, whereas a ground-based architecture can support a number of aircraft simultaneously, even that are too small to carry those technologies on board. So there's a lot of mixing and matching and economics to balance over whether I put a detect and avoid technology on every drone, or I build a ground-based infrastructure to support all of my operations, or hey, maybe as a business, I instrument the ground network and charge for my services, and you can subscribe to my detect and avoid service in order to, meet your safety case.
Okay, so Christian, when we talk about ADSB equipage for aircraft operating in these areas along with drones, for instance, in a rural area, we've seen waivers for drones to operate beyond line of sight if they shelter within 200 feet of the ground. And so, how is that concept playing alongside the equipage and the right of way issues that you just covered with us?
Good question. So I would expand your description to not just include within 200 feet of the ground, but also nearby shielding objects or underneath the highest obstacles. The idea
Yes.
being there's not going to be an aircraft flying theoretically below tree line, or below power lines, below bridges, right? And so using these natural and man-made structures can provide a level of risk mitigation that is acceptable to the FAA for detect and avoid capability, or not even detect and avoid, because you're not even detecting and avoiding, but your shielding or shadowing operation is using those structures to protect your operation and protect from other aircraft in the airspace.
Yes. Now, but the use case that I want to make sure that we cover here would be something like agricultural spraying, where you might have a crop duster that is operating on a farmer's field, obviously at very low altitude, and his neighbor might be running an automated drone that is doing spraying on the field next door without a human operator monitoring it, eyes on it the whole time. It's just going all day long, refilling and spraying the neighbor's field. How is that going to be resolved? Right. As we talk about this picture here.
Yeah, it's a great question, and one I've got recent insight to, because about 6 months ago, I joined the uncrewed agriculture aviation systems subcommittee for the National Agriculture Aviation Association. So the Crop Duster Association, right, has a UAAS subcommittee, and I have been to two subcommittee meetings now, and it is fascinating. It's a fascinating area of aviation that I've never had exposure to, right? And their concerns are completely different than us as typical aviators, right? They are terrified of this problem, and they're providing recommendations to their industry members that before diving into a field, they do a circling turn around the field, not only to see if they see any drone operators down there, but to warn the drone operators that they're getting ready to come in, right? And so they're trying to communicate within their own industry. They're different players within that same industry. They've got UAS, spray operators, and they've got crewed aircraft spray operators. They're trying to get some sort of collaboration going on in communication and best practices between those two providers so that they can avoid a catastrophe, right? And they're not talking about doing this from a technology standpoint. They're trying to figure out what radio frequencies can we use, right? They just approved a radio frequency for ag sprayer to ag sprayer communication, so they can verbally talk to each other if it's kind of a dedicated channel just for that between them. And how do they communicate that they're coming in on a field? How do they alert through circling turns around that field in order to try to coordinate? Now the risk is they've got somebody that's kind of rogue and not part of the industry and not part of that communications channel, but yeah, they're terrified of this. They're literally terrified of this. They're it's a huge concern for them.
So back to Peter's question, how's that thinking of being solved?
Communications primarily. They're not thinking about it from a technical perspective. They're thinking about it primarily from a communications perspective. We've talked to them a lot about equipping ADSB out systems on the crop dusters. The crop dusters and ag aircraft community is sort of notoriously not want to be tracked for competitive purposes. They're literally afraid that their competitor will see which fields they're flying, right? And so that goes back to this sort of inappropriate use of the technology. And so there's a mindset that needs to get incorporated into that pilot base there, that safety first. They're a very safety oriented organization, but they're skeptical of ADSB. And we're looking at solutions that would be available to the drone operator at that field to provide an audible oral alarm if there's an ADSB equipped aircraft in the area, right? Versus having to have them look at a screen with a moving map and dots on the map. Something that will blare at them if it comes within a bubble of airspace around them is a way to sort of help them do that. But that requires the crop duster to be equipped, right? But all of these little pieces and layers.
Right. And I'm also, though, looking a few years into the future where there is no drone operator attending to the drone while it's doing its job. The drone is operating from a dock, and it automatically refills whatever material is being sprayed at that dock. And it is just covering the acreage throughout the day, ferrying back and forth. And so there is no drone operator paying attention. The drone operator is off doing other things on the farm. And so in that case, the drone system itself would have to have ADSB in, and it would have to be avoiding the crop duster on its own. And the crop duster would have to have electronic conspicuity. And as you point out, this is one more instance where the identity that is transmitted with ADSB is unnecessary, and it's causing a problem with adoption. It's such a contrast to the automotive world where we have no way to reverse look up license plates. And yet in an ADSB world, anybody can find out so much information about the aircraft, which leads to these competitive concerns and everything. And so it's just one more point in terms of why can't we have an anonymous electronic conspicuity and do that across the spectrum. But for the spray operation, it seems like that's the avenue that would get us to a system that works, that's acceptably safe for this type of spraying, unless I'm missing something.
No, I think you're right, and you hit an important point there, which is I think one of your questions is the future of what's happening in the next 5 years and what's happening in the industry. I see a trend towards a lot more dock operations, and a dock operation isn't really what we initially thought of when we were thinking BV loss, and at least in my mind. In my mind, BV loss meant long distance, right? But a dock operation may not be long distance from the dock, right? It's just being operated from a remote operator. And so you don't necessarily need long range communication links or long range detect and avoid infrastructure, because your operational area is still within a local area of your dock. It's just that you're flying that area quite frequently. You're just flying it from somewhere else. And so I do have another customer that is very similar use case. It's not an ag use case, it's a security use case. And they are deploying docks and detect and avoid systems in rural areas, right? And so they're specking out the dock systems, and they're running tests on various detect and avoid technologies, CASIG being one of them, in order to determine the best non-cooperative sensor to pair with each dock operation, for that type of operation. So more technical problems to solve for refueling ag sprayers and things like that. But this is, nearer term, there are security applications that where what you're talking about is absolutely real.
Hey, Christian, Luca asked a few minutes ago about dedicated use and sole use of ADSB for air traffic. You received a contract sometime in 24 for the FAA Service Awareness Initiative. Congratulations on that win. Talk about that, its use case for surface monitoring.
Yeah, this is a great example of what you can do in a mandated airspace at a much lower cost, right? And so this is, I think I talked about this last time I was on the show with you guys, but there are airport surface detection equipment systems that are deployed at the 44 largest airports in the country. It's called an ASDX system. It's a combination of ADSB receivers, radars, and multilateration systems, and it fuses all of that data, and it tracks everything going on in the surface system. It costs millions and millions and millions of dollars per airport to install and run those systems. And about 2 years ago, when Billy Nolan was the administrator, he initiated a sort of an emergency safety panel in response to a bunch of near miss incidents that were occurring. And one of the recommendations was find commercial, lower cost solutions to deploy to smaller airports, and a lot of them for airport surface situational awareness. That became what is known today as the Surface Awareness Initiative, right? And so what they did was they ran a competition, and the idea is that there wasn't going to be one single vendor available to provide these systems. And so they were down selected to three vendors: ourselves, Saab Census, and Indra. And so the three vendors over the course of the last year each got contracts to deploy to a number of airports. To date, in 2024, they deployed an initial set of 4 and then another set of 4, so 18 airports in a year. So we went from concept to deployed at 18 airports across three vendors in 1 year, which is pretty damn awesome from an FAA acquisition and deployment standpoint, right? And examples of these airport sizes are Nashville, Tampa, Dallas Love, right? So mid-tier sort of airports that are, regional, mid-sized hubs for airlines.
The ones you deployed at were mid-sized to smaller in Florida, right?
Some of them, yeah. So we did Tampa, which is the largest one we've done, but we also did Sanford, which is quite small. We did Tamiami, which is an executive airport, doesn't even have commercial flights into it. Daytona Beach, PBI. So we have deployed 8 so far, and the other critical piece of the deployment is that we each have a requirement to, from day one being turned on for an airport, have 90 days to install and qualify and go into full operation. So we get turned on 90 days, right? And we get turned on for, multiple airports at a time. So we're in Florida, we went 6 airports in parallel, 90 days, got them all installed and qualified within 90 days, right? So we're super, super proud of that. We think that's super exciting future for us. It's really important, I think, also in drawing an analog between what we're doing for air traffic control. And it is a situational awareness only tool, meaning that they can't rely on this only to separate traffic. They still have to use all of their normal procedures for voice and visual, kinds of procedures. This gives them another tool. Everything we've heard is they love it. So we're getting great feedback from the controllers, which is very gratifying to hear from them, But there's an analog to, hey, if we now have defined a surveillance service that's acceptable for this use case in separating traffic, a very similar service could be deployed for detect and avoid capabilities for AAM or drone operations. So, how good is good enough is a good question, right? A good way to put it. This is not a multi-millions of dollars, installation at an airport. It's relatively cheap in aviation dollars, and so that is good enough for that. So now we can draw upon that and expand that into other use cases.
But there is a little bit of a difference, isn't there? If somebody's not cooperating, if somebody's not equipped at a Orlando Sanford, let's say, there's still immense value for all the people who are equipped. I think you also deployed ADSB and other vehicles as well. So so there's still a lot of value. But the corollary to, let's say, the terminal airspace is that it's really not good enough if somebody's not fully equipped. How do you feel about that? What's the differences between the two?
Between airport surface and terminal airspace.
Right. And cooperative and non-cooperative aircraft.
Yeah. And that is the exact reason why they cannot rely on a surface awareness display only for traffic separation, whereas they can an ASDX system, right? So an ASDX system, that extra millions of dollars gets you the ability to use it only if you had to, right, for that purpose. And so this you cannot. Now, from a terminal airspace perspective, there is a follow-on program coming called the APRT program, Airport Reporting Tool. They tried to create a clever acronym out of it. Same idea though, which is low-cost surveillance. They are thinking about bringing in options for non-cooperative sensors in, right? So it's ADSB, maybe plus something else, not necessarily. It's call it. I'm going to think maybe 2 years behind SAI because they want to sort of get some lessons learned from an SAI deployment before they start to roll it out to other systems. And this is part of the next gen surveillance system I talked about previously was a system called STARS, which was an upgrade to many of the terminal service radars. And most of the FAA towers have a STARS display in the tower. But a lot of people don't know this. A lot of air traffic control towers are privatized, and they're called federal contract towers. And those privatized towers often don't have a display. And so this APRT system is meant to help those privatized towers.
For the SAI initiative, what is the product that the controllers are using? Is that a display that shows the map of the area surrounding the airport with ADSB returns kind of superimposed on the map? And what is the biggest value prop that you're hearing from controllers?
We physically install a monitor in the display, or somewhere between 1 and 3 monitors in display, and 1 monitor in a TRACON typically. So an airport will have, call it 2 to 4 displays in general, right? And so they get a physical monitor mounted to their air traffic control desk. It's an airport map, a simplified airport map showing all the runways and taxiways. It shows airspace expanding out to about 10 miles around the airspace, right? And so they get to see incoming traffic, outgoing traffic. Typically, they're focused in on the airport surface itself. They've got the ability to create sort of insets where they might want to look at an approach corridor. So they might want to be zoomed in on the airport surface itself, but they've got a little window up in the upper corner that shows the aircraft on final, so they can see someone's coming in. There are no alarms. Alarms are a function of a safety logic that kind of gets you to that fully certified capability. So this is something that they have to look at in order to see. They see aircraft, overlaid on the map. They see data tags for those aircraft, so they get to see what the call sign for their aircraft is. They get to see the tail number if that's applicable. They get to see the speed, the altitude, and aircraft type if we know the aircraft type. So they would know it's a 737 versus a Cessna 172, which is really interesting because we installed it at Daytona Beach. Embry-Riddle is based there, as well as 2 other flight schools. That is the absolute busiest airport that I've ever been to, right? And they line up Cessna 172s side by side on taxiways, like 2 deep, rather than 1 in a row. They line them side by side in tandem. It was crazy to see that. So,
what percentage of the planes at Daytona Beach are not ADSB equipped?
in my time I spent there, I saw 1 aircraft that was not ADSB equipped.
So it's an FAA contract. Does the data also get passed to the airline and to the airports, or is it only the FAA?
It's only the FAA, but it is available to others if they would like to get it. Our service delivery is of the display with the data in it. We're not delivering a separate data feed, if you will, right? It's not like the SBS program, ADSB program, where they get data into other parts of the FAA system. This is self-contained within our system, which is also an important point. We are not allowed to use any FAA networks, right? So we are completely off grid from an FAA perspective. So we have to bring our own networks, we have to bring our own communications. It's a completely sort of off grid system.
And are those opportunities now for you, the FBOs, the airport, the airline? Those are all business opportunities for you to be able to expand.
Yeah, right. Yeah, and you also mentioned that we have a product that enables airport vehicles to be seen by these displays as well. So we have an ADSB out system for airport vehicles to prevent what just happened in Brazil, where an aircraft took off and hit that pickup truck that was on the runway.
So was it, I have to ask, was it your landing fee system that triggered the ADSB?
It was not. It was not. No, it was not. We do not have a landing fee system. Be completely clear with that. We do not have a landing fee system. Yeah.
Very cool. Christian, let's talk about industry trends real quick. Is this something that you'd like to highlight either in general aviation or UAS?
I hit on the docks, the growth of docks. That was going to be one of my topics. There's definitely a growth in dock usage. I think docks are coming down in price compared to what we saw a few years ago. So some quite large systems that were out there, they're still out there, but we're seeing, Skydio get quite small, DJI get quite small. And, I've heard sentiment, although I haven't seen it commercially, that there's desire for a dock architecture that is drone agnostic so that customers aren't vendor locked and they can upgrade their drones over time but still maintain the infrastructure that they invested in, right? So I think that might grow to be a trend there. In the GA space, there is still growth in delivery of piston engine aircraft. So the GA aircraft deliveries over the last 5 years have increased, usually single digits, but once or twice, I think 2 years ago, I think we hit like a 12% growth. It's not a huge amount of aircraft, or it's under 2,000 new aircraft delivered every year, but it's good to see that that industry is healthy. The cost of those aircraft are getting higher. There's a movement called Mosaic that'll be able to certify lower cost aircraft, and so I'm hopeful that will improve access to the flying community. There's always AOPA reports always a very strong number of students in flight training that's occurring out there. So there's always a full pipeline of students coming into the industry. They get attritted out over time due to costs or whatever over time. So hopefully, if we can lower those costs and make things safer for them, they won't attrit, and the industry will continue to grow. In the avionics side of GA, a lot of additional safety enhancements, auto land systems, things like that from Garmin. A lot of movement towards, or NTSB made a recommendation not long ago for AOA, angle of attack systems should be installed on all GA aircraft because we're finding that they prevent stall-based crashes. Parachute recovery systems like Cirrus has. So a lot of safety-based systems that can provide more confidence to the pilots that they'll survive if there's an accident.
On the dock drone arena, are there particular use cases where you're seeing the most growth in, or more broadly, where do you see still the bottlenecks? You talked about hardware and having a cross-platform hardware piece. What about the software?
I don't have as much insight into the software applications that run those docks. I have seen 3 major use cases for them. One is utilities. So utility companies installing docks at substations and perform routine inspections based in their substations. So substations are fenced off, they're nicely protected. They can fly a couple miles, up and down that infrastructure. So installing docks at utility locations. The second is DFR use cases. So police installing a dock on top of City Hall or the sheriff's office, and using that as when a call comes in, the drone is overhead before officers show up, and they have a better idea of what they're approaching. Right. Chula Vista has a great video of a win there where they There was a call that potentially an armed man on the sidewalk, right? And the drone was able to determine that it was a cigarette lighter, right? And so they count that as a win, avoiding a catastrophic situation. And then the third one is similar security, not necessarily in the DFR getting to a site first, but more of a security of a patrol of critical infrastructure. So sort of like the utility use case, but from a law enforcement perspective. So patrolling and monitoring reservoirs or power plants, for example, from a security perspective. So I've seen those as the most dominant use cases from the dock customers that we've had.
And as we're closing, I'd like to touch on one additional thing that you and I talked about in preparation for the podcast. And that's on the topic of avionics in UAS systems, in drones. And obviously, uAvionix has been a pioneer in this field. And over the years, there has been this observation of a spectrum of certified design assurance avionics versus off the shelf, non certified components plus flight heritage as ultimately getting an operator to an approval to fly complex operation. How have your expectations of where the market is in between those two extremes, and how do you see this evolving?
You're right. Call it 5 years ago or more, the industry was in this expectation that BV loss capable drones are going to have to obtain a type certification, just like a Cessna would, right? And that type certification is such a laborious task from a manufacturer perspective that the components inside would also need a certification, the relevant certifications, whether it's a TSO or STC or something like that. And because that's the analog in the manned industry or the crewed industry, right? If you're going to type certify your aircraft, you need certified systems on board. That system needs to be approved for that installation on that aircraft. Over time, we have seen that that may not hold true always. Partially due to the lack of process and regulation and the ability of the regulators to actually achieve the type certifications, while in parallel the rest of industry is moving forward and proving safety through actual operations and history and data collection. I'm seeing that relaxing of a design assurance based certification in favor of a performance based certification. Now, I think that some components like transponders might be an exception because, a transponder communicates your position to the rest of the airspace users, right? And so we've heard in the past that, that's a critical piece of the safety of the NAS, not only for the aircraft that it's flying on, but for everyone else around them. And therefore, that piece requires a certification. But for the airframe itself and all of the systems on board that only affect that airframe, performance-based reliability seems to be getting good enough. And we've looked in the past at should we build certified autopilots. We've held off on that kind of a thing, and because, gosh, people are getting away with cubes, very high performing, 10 years of performance, if not more, amazing pieces of hardware that are supported by an open source community that will never be certified for that reason. And gosh, it's probably in the majority of platforms out there. So performance, I think it's a good thing overall. It has changed our strategy a little bit in terms of how we think about the products that we want to bring to market, because everything may not need a certification.
Christian, when you were on a couple of years ago, great podcast. What's the biggest thing that's changed in the industry?
Wow. Well, the biggest thing that changed is that we thought we were so close to Part 108. Back then, I don't think we had a really good timeline of BV loss rules and when that would be. And there's been a ton of work done since then to get us to an imminent release of the NPRM. And so I think that built a lot of confidence up in, every year that goes by that we don't have that, we get more companies that don't survive. And I think building up to that with the confidence that that NPRM would bring probably it reinvigorates investment from VC firms, from PE firms, from corporate investment that we're moving out of this early phase of the industry into something more sustainable and predictable. Not quite there yet, but
All right. And
but
then let me ask this. Have the recent incidents and accidents had any impact whatsoever on Part 108 approval? Or is it completely unrelated?
I think the December New Jersey hysteria. I think it I think it probably pushed pause, right? In my knowledge from working with the industry advocacy groups that we work with, it was touch and go all the way up until inauguration day as to whether or not the NPRM was going to go live or not. And I think that probably killed it for the time being. Not killed it for good, but for that imminent release. I don't know that for sure, but I feel like that could be the case.
I mean, I would interpret it as an even greater urgency to put some regulations out.
To me, it highlighted a little bit of the bubble that we live in this industry versus broader society, their exposure to drones and what a hysteria that caused when they thought drones were flying around them.
Right. Good point.
You know?
Yeah. I also wonder with 108, and I think we talked about this previously, the new administration's desire to retire a couple of regulations before putting a new regulation out.
Yeah.
Whether 108 might be spun as, yes,
Deregulation. Yeah.
deregulation, getting rid of all the waivers and exemptions, and 107 perhaps, and encapsulating that in 108, or whether that will be viewed as yet another layer.
Yeah. Yeah, I know that's the current objectives, right? Is to try to educate the administration that this makes things a lot easier, right, rather than harder.
I mean, Part 108, in a way, de facto alleviates regulations that we're currently limiting the whole industry with right now. So it should be viewed differently.
Well, it was a real pleasure having you back. Thank you again for your time. Really enjoyed it.
It was fun. Thanks.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.